For this video, we will cover how to complete autosomal recessive pedigrees. Let's start by talking about the items that we use to identify a pedigree as autosomal recessive. Affected children may have two normal parents. Two affected individuals cannot have an unaffected child. This tends to skip a generation. Males and females have an equal chance of being affected, and around 25% are affected. With that out of the way, let's take a look at a pedigree and go through some basic ways to complete it. Let's start by adding in all of our known items. Since this is a recessive trait, we know that all of the shaded individuals have to have two lowercase letters. Let's just use A's to make it easier. So let's give them all two small a's. Next, we know that all the unshaded individuals then have to have at least one uppercase A since they do not have the trait. With that out of the way, we can now start asking the question, what is the second allele for all of the unshaded individuals? We're basically going to just look at the parents and offspring of each individual and see if we can determine or justify what their second allele has to be. Keep in mind here that we won't be able to justify a homozygous dominant individual, or big A, and as such, we may end up with some question marks. The question mark simply indicates that it could be either a dominant allele, big A, or a recessive allele, little a. Let's start with individual 1-1. This individual has no parental information, so we have to look at the children. This individual is going to be heterozygous, or big A, little a. The justification here is individual 2-4. Since mom is only able to give off one recessive allele, the son had to have received the second allele from the dad. Let's go ahead and skip individual 2-1 and move to individual 2-3. This individual also has to be heterozygous. The justification is individual 1-2. The mom can only give off a recessive trait, meaning individual 2-3 would have to have received their dominant allele from the dad and then received a recessive allele from the mom, as she cannot pass on anything else. Now let's talk about individuals 3-1, 3-2, and 3-3, as these are all going to have the same genotype due to the same justification. Here they're all going to be heterozygous. This is the same justification as the one above. The mom can only give off a recessive allele, and they had to have received a dominant allele from the dad. Now let's finish up the pedigree talking about individual 2-1. We have no parental information to use, so we have to look at the children, individuals 3-1, 3-2, and 3-3. However, we hit a bit of a snag here. Since none of the individuals are expressing the trait, we cannot justify individual 2-1 as being heterozygous. And since we can never make the assumption that an individual is homozygous dominant, we then have to say that he is big A ? We know that he has to have at least one dominant allele, but we cannot justify the second allele. However, that does finish off our pedigree. Let's take a look at a second one just to get a bit more practice. Let me quickly add in the generations and the individual numbers. Let's start by adding our knowns. Each of the shaded individuals receive two small a's, and each of the unshaded individuals receive one big A. Now let's ask a question. What is the second allele of the unshaded individuals? Let's start with individual 1-1. There is no parental information, so let's look at the kids. None of them are displaying the trait, so we cannot justify a recessive allele, and we cannot assume a dominant allele. So she should be big A ? Now on to individual 1-3. There is again no parental information, so we look at the kids. Here she has two kids that are recessive, and since both of these kids both have to have two recessive alleles, this means that both mom and dad would have to donate one each. So she would have to be heterozygous to meet this justification. This would then also apply to the dad of the kids, or individual 1-4. Alrighty, one generation down, let's move on to the next. Let's talk about individuals 2-1, 2-2, and 2-3. These are all going to be heterozygous. They receive the dominant allele from their mom, and dad can only give off recessive alleles, so they end up heterozygous. Now let's move on to individual 2-4. This individual does have parental information, but since neither parent displays a trait, we cannot use that information to make a justification. However, she does have one child that displays the trait. This child again would need to receive a recessive allele from both mom and dad, and as such, mom in this case, or individual 2-4, would have to be heterozygous for the child to be homozygous recessive. Now on to individual 2-7. Here, we're in the same pickle as we were in the question above, but we do not have any offspring information to help make a justification. As such, we will have to make this individual a big A question mark. The reason here is that we know that both parents are heterozygous. So, let's say the mom donated the big A that individual 2-7 has to have. There's now a 50% chance that dad donated either a big A or a small a. In a similar fashion, if dad donated the required big A, mom would have a 50% chance to donate either a big A or a small a. As such, we cannot justify the second allele and have to keep it as a question mark. Lastly, we have individual 3-1. This will also be a big A question mark. Again, we have two heterozygous parents, and while we know that at least one of them donated a big A, we cannot justify what type of allele was donated by the other parent. At least not until we get offspring information. Keeping these simple rules in mind should make you able to complete autosomal recessive pedigrees without too much trouble. Always start by confirming that the pedigree is in fact autosomal recessive, then add your knowns to complete as much of the pedigree as possible, and then just ask, what is the second allele of the unshaded individuals? This concludes our video covering how to complete autosomal recessive pedigrees.